This video is brought to you by Simplistics, because sometimes the data need a good interrogation.
The night sky is a crooked witness. Astronomers stare at it through brass tubes and polished lenses, jotting down numbers like detectives collecting alibis. But the universe never tells the same story twice. One night a planet is here, the next night it's there. Little left, little right. The measurements don't line up. They never do. You take 10 observations, you get 10 equations, all trying to pin down 3 unknowns. The math doesn't balance, the system doesn't close. Too many statements, not enough suspects. In the trade, we call that overdetermined. In plain language, it means the universe has given you more testimonies than you know what to do with. And some of those witnesses are lying. Not maliciously, mind you, but the questions remain. If the observations don't agree, how do you decide what truth to believe? That little puzzle pulled 3 of the sharpest minds in Europe to tackle the same problem in the same smoky room. And like most smoky rooms, filled with brilliant men, the conversation got ugly. Let's start with the philosopher of the bunch, Joseph Louis Lagrange. The man had a brain like a cathedral, and the personality of a librarian who knows they're the smartest person in the room.
When observations disagree, the goal is not to panic.
He adjusts his cuffs.
One asks a simple question. What estimate is most reasonable given the errors we expect in measurement?
A thoughtful pause filled with implications.
One might minimize the total magnitude of these errors. Absolute deviations, for instance. A clean criterion.
A faint smile creeps in.
But mathematicians are not known for their restraint. Some of my colleagues later developed more flamboyant approaches.
He glances, slightly off camera, as if it's beneath his notice.
Flamboyant and unnecessarily dramatic.
Yes, Lagrange was the gentleman in the room. Which is to say, he was the only one who wasn't openly accusing anybody of theft. Intellectual theft. Theft of the worst kind. That left the field wide open for the probabilist. Simon Pierre Laplace. If Lagrange was the philosopher, Laplace was the prosecutor. The man believed probability could explain everything, from planetary motion to the fate of the very universe.
Measurement error follows laws.
He taps the table with 2 fingers in annoyance.
Once you understand the distribution of those errors, the mathematics becomes obvious. The most plausible estimate is the one that maximizes the probability of observations.
He leans forward slightly.
In many cases, this leads to minimizing the sum of the square errors.
A thin smile appears.
The conclusion is quite natural, if one actually understands probability.
A pregnant pause.
Unfortunately, not all mathematicians do.
He shrugs.
Some prefer to discover ideas retroactively.
That last line wasn't subtle, nor was it meant to be. Because across the Rhine, a young German mathematician had just stepped into the scene. And he was about to make everyone look slow. The incident, Ceres. In 1801, astronomers discovered a new object in the celestial sky. Ceres. For a few brief nights, they tracked it in the sky. Then, just as suddenly as it appeared, it slipped behind the sun. Gone. When it returned months later, nobody knew where to look, except for one man. Carl Friedrich Gauss. If confidence could be distilled in human form, it might look like Gauss, but with slick back hair.
The orbit was not lost.
He folds his hands.
The observations were merely inconsistent.
A meaningful pause.
When you possess more equations than unknown parameters, the correct procedure is obvious. Choose the parameters that minimize the square discrepancies.
He said it as though describing how to tie a shoelace or a corset, or the noose around his opponent's neck.
The solution reveals itself immediately.
Another pause.
I had been using the method for years.
He glances sideways.
Though certain individuals prefer to believe that ideas only exist once they appear in French print.
That jab landed squarely in Paris, because a man named Lagrange had just published the method of least squares in 1805, complete with equations and a tidy explanation. And Gauss? Gauss claimed he'd been using it privately for years, finding the answer so obvious he never bothered to publish it in a paper. A claim which, depending on who you ask, was either brilliant or suspiciously convenient. Which of the two is a mystery that will never be solved, save in the mind of Gauss himself.
Adrien-Marie Lagrange,
the man who actually put the method in print.
I published the method, Clearly, explicitly.
He gestures emphatically toward a stack of papers.
1805. Anybody who cared to read could see it.
A sharp exhale, filled with disgust.
And then Herr Gauss informs the world that he'd been using the same method for years.
He tilts his head.
Ha! How fortunate!
Another pause.
In science, we normally call that a publication.
So the room filled with accusations. The plots indicated that Gauss did not understand probability. Gauss suggested that French mathematicians only discovered things after they'd been invented by Germans. Lagrange insisted that the only discoveries that count are the ones that are actually written down. And somewhere in the background, Lagrange quietly wondered why everybody was behaving like children. Underneath all the bruised egos, mathematics was simple. Observations give you equations. Too many equations. No perfect solution. So you measure the error between what the model predicts and what the telescope actually sees. You square those errors, so the positives and the negatives stop canceling each other out. Then you add them up. And finally, you find the parameter values that make the errors as small as possible. These squares. One simple answer. Extracted from a crowd of unreliable witnesses. In the end, the arguments didn't matter. Ceres appeared exactly where Gauss predicted it would be. Astronomers started using least squares to estimate orbits. Physicists used it to fit models. And statisticians built their entire career atop. And the mathematicians? Well, they continued arguing about who deserved credit. Which, when you think about it, is exactly what you would expect from a room full of geniuses staring at imperfect data, trying to decide who got there first.